Welcome to my talk. This is about pen testing and performing security assessments on IPv6. My name is Rick Hayes. I am a security consultant for a company. I'm not going to say who, but for a company. I'm also the host of the InfoSec Daily podcast, which you guys that attended last night, we certainly thank you. And so I saw one of the guys that was on there. But anyways, what I'm going to cover today is IPv6 and why does it matter, go through a brief overview of IPv6, then talk about assessing IPv6 networks, and then accessing IPv6 networks, then assessing IPv6 networks. And then I was going to do a demo, but we're probably just going to swing it and just go through the demo as we do the presentation. And just a little background on how this kind of whole thing got started was I was doing an internal assessment at a corporation and asked to look at their data center. So I came back and said, these are the results that we found. He said, so just run Nmap scans and find out all the boxes that you can see. And I should have known when he said that it was kind of a test, which I failed, because I only found half the boxes. So he said, show me what you've got. And I said, this is the listing. You know, here's all the Nmap results. And he goes, great. Where's the others? I said, what others? He said, the other boxes. He said, our dev and our test boxes. I said, didn't you give me the subnet you wanted me to scan? And he said, yes. He said, but I gave you the IPv4 subnet. You didn't ask for IPv6. And we have an entire half of our data center that is running IPv6 because we're trying to switch over internally. I said, great. Let me just fire up some tools and see what I can find. So I tried to fire up some commercial tools to find those devices, and I failed miserably because you don't configure them the same way. They don't work the same way. So I asked him what was his driver, and obviously we know what the driver is for moving to IPv6. It's the depletion of the IPv4, minus the whores that are keeping the blocks that are allocated to them. There's none left unless you're Verizon and other companies that. But as we say that, there's going to be a transition period. So a lot of folks are starting to look at IPv6. They're doing it internally, perhaps not externally, but internally they're doing it, and they're looking to transition. So we're in a period of flux, and probably going to be there for the better part of maybe 10 to 15 years, which is kind of cool because you think about it, that's a really slow learning curve. You can kind of get ramped up very slowly. But the idea is this is what IPv6 usage from the internet, and this is broadband, looked like circa 1999. And you can see it's not that great. There wasn't a lot. It was mostly geeks and universities that were doing it, and other people doing research, and probably not even security research. We step forward to 2011, and we can see that it has grown by leaps and bounds. That's a good transition that you see there. When you see going from that to this, that's a coverage area. So that being said, there are a lot of folks that have some ripe targets out there, if that's what you're into, but that are running on IPv6. A lot of your customers or our customers are running IPv6, and if we don't have the knowledge or the tool set to go out and assess them, then we're missing half the battle. So we got some changes going on. Right now we got IPv4 only devices. We got devices that are IPv4 and IPv6. We've got devices that are IPv6 only. So the issue is that this change isn't going to happen. It's going to be slow. It should be methodical, but you're going to start seeing companies doing their testing for integrating the IPv6 into their current infrastructure. Rather than going out to a marketplace and saying, I need to pay some kind of bounty to get an IPv4 address or block, I can just cheaply do it instead of changing over. If I'm going to change over anyways, why not just go over to 6 and be done with it? So real quick, and again, because I started out not knowing a whole hell of a lot about IPv6, so I figured I can't be the only guy that didn't know a whole hell of a lot about it. But if I say anything wrong, please correct me. If you know more than I do, which I'm assuming is most of you, this is probably just rudimentary. But IPv6 is obviously the next generation. It's the replacement for IPv4. It was developed by the IETF. And if you look and see when it actually came out in 98. So that's why that map of 99 becomes important. So, and again, it deals with packet switching, internet working, end-to-end datagram transmission. Here's the significant part. IPv6 uses 128-bit address, which supports 2,128. It supports 2,028 networks, and so that's 340 unit whatever. It's just a shitload. I don't know how to pronounce it, so I'm not going to tell you. IPv4 supports about 4 billion, and so we've already run through those. IPv6 eliminates the necessity to have natting, so we start getting back to like the old universities or current universities where everything's a publicly addressable IP address. So, yay. But the idea is we don't have to worry about the exhaustion of those, because by the time we exhaust IPv6, we'll be at V8, and so we can just continue to start looking at the next generation, probably 256-bit address, and nobody will certainly be able to remember that. So the days of us being able to say, go to, blank dot blank dot blank dot blank are over. So I say that, but yet what was the premise behind it? So they wanted to simplify the address assignment. So they put in some mechanisms that allows a device to be able to essentially auto-configure itself, unless you're a Mac. And I'll get to that in a minute. And so it provides for network renumbering, and again, all of this is just basic. It's part of the RFC, but the idea was they wanted to make sure the one mechanism that they included, which was we all know is a bolt-on to IPv4, was security. So IPsec is included in it. Now, a lot of people, you'll see the RFC says it's mandatory, but it's not. It's actually recommended. You don't have to use IPsec as part of an IPv6 implementation. You can run things unencrypted and still use IPv6. Because what it does is, for backwards compatibility, is allows you to be able to say, if a device talks to another device and says, sorry, I don't speak that lingo, meaning IPsec, then it says, oh, okay, well, let's talk plain text. And it goes, okay, and that's fine. So all you have to do is essentially say, I don't want to encrypt my datagrams, and it won't do it. So one of the significant changes that came out of that was obviously the new header format, and we're going to take a look at that in a second. The quality of service, and then they added something called Neighbor Discovery Protocol, which is essentially ICMP version 6, but it replaces ARP. So the notion of doing ARP poisoning is gone. Now, we also have router discovery messages and redirect messages and some other multicast and unicast messages, which become fairly important as we start looking at an IPv6 infrastructure. So just to give you a quick comparison, IPv4 is 32 bits versus 128. Again, you have the auto-configuration for IPv4 is DHCP, but you have to use DHCP version 6, which is optional. You have to use ICMP version 6. You have the router announcements, and ARP is no longer there, so you use ICMP. And again, you see where it says mandatory for IPsec. It's actually recommended if you read the RFC. So this is what an IPv6 address looks like. It shouldn't be any surprise to any one of you, but there's multiple ways that you could write it. So they figured that all those zeros were going to confuse us. So they said, hey, you could remove the leading zeros in the 16-bit block address, and you can make it look like that. Or you could just go with a double colon notation, and you kind of truncate it down. So all three of those are legitimate IPv6 addresses. Different operating systems present them differently to you. So it's important for you to know how those work.
All three of those were the same?
All three of these are the same exact IP address. So auto-configuration. IPv6 hosts, with the exceptions of Macs, can auto-configure themselves to get an IPv6 address. So what they do is they use a router discovery message, which is what actually is required, and Apple implements that. But the thing of it is, if it doesn't receive a message back from a router, it says, I need to find a DHCP v6 server. If I don't see that, then I say I have no capability of assigning myself an IP address. So if you set your Mac or any system to using IPv6 and you say automatic, go and see if it gets you an IP address if you do not have a router that says this is what you need to be using, because it has no concept of what the local link is. So again, going into IPsec, the same thing for IPv6 applies that was relevant in IPv4. It provides that whole CIA confidentiality, data integrity. The one thing it does provide is the authentication. So you can actually go through, if it's enabled on IPv6 and both sides agree to it, you can actually say, are you the one that sent me this packet? And I can validate that you're the one that sent it to me. So, I mean, think about that from a man-in-the-middle perspective. That kind of changes the paradigm a little bit. If you have anti-replay, again, I can't do a packet capture and just replay those packets back over, because I can then go and verify that those packets were unique and they weren't duplicated. They haven't been seen out on the wire before. So this is the significant change. Now, when you start looking at IPv4 header, everybody's seen those. We've seen them hundreds of times. So, I mean, that's nothing new. But the fact of the matter is, everything that's in yellow on that, and unless you're colorblind, I will kind of point it out, it's those. Those are actually the ones that are carried over because they wanted to keep them the same from IPv4 to v6. So you can see that it's significantly changed in the sense that it's more simplistic. So they achieved what they wanted to. So they didn't include a lot of the other stuff, and there is some. The flow label, we talked about quality of service. That's the actual flow label that will go into that particular part in a header. So I talked about ICMP v6. Again, it's defined by RFC 2463. This is just what a packet looks like. So you see the previous IPv6 header. You have the IPv6 payload compared to what you would have down. So that payload that is going to consist of an ICMP v6 header and that message is all going to go into the IPv6 payload. I just want to say v6 versus IP. So the ICMP v6 provides a multicast listener discovery and neighbor discovery. And that multicast listener discovery kind of becomes important, but the neighbor discovery is extremely important because it tells you what? Who's your neighbor? Who's on the same wire that I am? And what that defines is I am not crossing a router. That's what that's defined as. So, and again, it replaces IGMP for those of you that are interested, but it also makes sure that it has your membership management for the multicast segment that you're going to be on. So, for those of us that are used to dealing with multicast, nothing's really changed. It's just the addresses have changed. This is what the new v6 multicast looks like. So when I want to ping everybody, I actually can ping this address right here, ff02::1. Now, if I want to see all of the routers that are on there as well, ff02::2. So you can go through and you can see that this is kind of cool that you can just ping that address, and I've essentially done a ping sweep of everybody on that. So they will all reply back, I'm here. So neighbor discovery. It determines the link layer addressing. So what it does is, think about it. It makes sure that I don't have a duplicate address. You're not going to have the same v6 address that I have. It's also going to make sure that I know of the routers that are out there. It's going to make sure that I know all of the neighbors when they come up and when they come down, because they announce themselves of doing so. Now, when they go down, if it's in like a hard crash, they just won't be there. But generally, when they're being shut down, they're nice. They send out, hey, I'm going away. I'm going bye-bye. I'm not going to be here. One of the things that the ICMP v6 actually has is those 5 main packets, which is a router solicitation. Who's the router out there? Router advertisements, I'm the router. Neighbor solicitation, who's my neighbor? And again, advertisements, yeah, I'm your neighbor. Trust me. And of course, then the redirects. And again, the redirects are the same thing that we've seen from v4. So we talk about DNS. And this is where it actually becomes kind of interesting, because we have A records now. With v6, we have quad A records. I don't know why they got so original that they just came out with quad A, but still. And we have the pointer records or the reverse records that are exactly the same. So a lot of applications right now rely, from a v6 perspective, rely on DNS. So they're going to query a host name. So that's problematic if you think about trying to just say, I need to see what's out there. So I'm going to say, hey, send me all of the, neighbor solicitation. Who's my neighbor? Talk to me. And they all tell you, and you're like, cool. Now I want to talk to you, but all I've been given is your v6 address. I don't know who you are because it doesn't announce the host name in that. So accessing, how do you access? Now on a local subnet, it was fairly easy. I just plugged into an RJ45 jack, and Bob's your uncle, I was on their network. If you're wondering what operating systems support it, that's the shit ton that do. Most of them by default. And some of them support them IPv6 better than others. But for the majority of them, if you think about Windows 2008, it's enabled by default. 7 by default. Keep going down the list of all of the ones that it's enabled. Ubuntu. All of it's on by default. Now the interesting thing or the scary thing is if I go and I actually, so how do you enable it? So I'm going to show you, basically you can, on a Mac, and this is Mac specific. So essentially, I have to go through and I have to tell it that I want to add it to all. Okay, now I've already done it, so it's going to come back with an error, but you can see what I've got there. Now, if I want to see the firewall list, and this is by default, have not changed it. Does that look good to anybody? And I don't know if you can see that, so I'll read it. It's all 65,535 ports allow from any to any. That's the default firewall rule. That's when, if you're on our side, it's bad if you're not. So, so that being said, there's some fail built into this. So if you have an IIS box and you've set up rule sets for IPv4, you have to do the same thing for IPv6. And they're not the same commands. So if you're coming in from an internet perspective, you don't have IPv6, you don't have a provider, ISP that does it, what do? Go to Hurricane Electric, get you go find a broker. There's tons of them out there that support, I say tons, there's 3. But they're geographically dispersed, so there's tons, I guess, geographically. But you just go. It's free. This one's free. You can register. They ask for your publicly facing IP address, and that's it. There's clients out there. Okay? Now, here they are. So GoGo6, Freenet, they're actually cool, except for the only part is they only cover Montreal, Amsterdam, Taipei, and Sydney. But damn, they got a great-ass client that works well. So what do they support? 6 into 4, which is IPv6, into 4, and 4 into 6, which is IPv4, which is what we would want. We would want our 4 networks to be able to talk to a 6 network. Hurricane Electric covers the U.S. And again, it supports, well, U.S., Canada, Europe, Hong Kong, Tokyo, maybe not so much. Singapore, and it does 6 into 4. And 6 also does U.S., Brazil, and Europe, and that's a 6 into 4. So that's really what you're looking for. From an external perspective, if you want to assess a customer and you don't have that capability, get a broker. It's fairly easy. The EULA allows you to do that. In fact, most of them include the tools right on their websites to be able to assess which ports are open on an IPv6 network or internet-facing system, because they're assuming it's a regular laptop or something else that's public-facing. So assessing an IPv6 network. So where the rubber meets the road. So when we normally do a v4 reconnaissance, normally when we do reconnaissance, we say, hey, just run a ping sweep and find out what's alive and go through that. Or we may do a full port scan, all 65,535 TCP and same thing. So we may do all of that to find out what's out there. That sounds great. We can see which ones don't respond to a ping. We can go through the whole myriad of things. In a v6 environment, you can't do that, because essentially you would be sending whatever that equates to. It's a shit ton, because it's like it's so many zeros, it's not even funny. The point being, it's not feasible to do a ping sweep of an entire v6 network, because guess what? If they're routing that, you're also talking to internet-facing systems. You're talking to universities and other folks that are running v6. So doing that to find out what's alive is problematic, as you can well imagine, which is kind of what I ran into. So quickly on a droid, without the customer knowing, I went and found out, how do I discover what's out there? Well, looks like you can go and you can query those quad A records, but you have to know the DNS server to be able to query them. Well, that kind of sucks. You have to know the IP address. Well, shit, I didn't know that. And for the most part, all of this required DNS, because even if I had to start with a host name and kind of work backwards, and I didn't have any of that. So I started looking at some other recon tools out there. Ping6. So you can use Ping6. It's installed by default on Backtrack, and I think Ubuntu, Mac has it. You don't have to have a Ping6 version with a Windows box. Ping works on IPv6 just natively. It works on v4 or v6. So you could use Nmap. Nmap's kind of quirky, though, and we're going to talk about that in a few seconds. You can use a half-scan 6, the v6 version of it. Metasploit, Netcat, Ncat, SoCat, and then the THC IPv6 Attack Toolkit. That's the Mac Daddy. That's the one you really want to get. It's not included by default on Backtrack, so you got to download it and install it, which can be problematic if you don't want a customer to know that you're doing it. So that's why we're having this talk, so you'll know to have your tools together ahead of time. Ping6 does exactly what it says. It pings. And so you can actually, but you have to know the address that you're going to ping or the host name. And again, if you have a host name, it has to have a v6 resolver, so the DNS has to come into play. But you can see that I can actually kind of trick it. I can say, oops, I want to ping all of those. Remember that FF02's ::1 we talked about earlier for the multicast? If I ping that, it tells me which ones are alive. So I have every one of these, and you can see it's sequentially doing 2 of them, and then a third one pops in. So I have, just to ignore the FE80, but 20C, 21F, and A6ED that pops in there. So it tells me how many duplicates, again, because remember we talked about the fact it's saying how many, remember we talked about replay, so it actually knows, and it uses that capability. Nmap. Nmap has some limitations. It's a great tool. I absolutely love it, but the only thing that's a limiter about it is it only does TCP connect. That kind of blows. You can do a ping scan, you can do a list scan, you can do version detection. It does all of the other stuff that you would think it does. So let's go here. So if I run a Nmap on a, well, here's one that I ran just like a few minutes ago, but essentially all I'm doing is telling it that I want to run v6, so I put a -6, I want it to do TCP. I tell it I don't need you to get a response or assume the box is dead. Okay? And then in that case, then it does the port mapping, and it comes back and tells me those. The interesting thing is, if I run that, and I'm going to get to that, well, I'll get to that in a second. So that's the actual results that we would see on Windows 2003 box, I think I have. Yeah, so this is the same thing. This is a Metasploitable box, I think. Yes. So if I do a comparison between a v6 and a v4 scan, and this is a 1025.132 versus the v6, can you see the difference? If you can't, I pointed them out for you because it took me a little bit of time to figure it out. There's some changes. Why? Because there's rule sets that are set on there by default that allow certain things to work and certain things not to work. If I hadn't allowed those, so the key one is I don't have a web server if I'm looking at it from a v6 perspective. So I can't attack a web server via v6. The same thing can be true inversely. I could also have services that are available on a v4 network and then, I'm sorry, on a v6 network that are not available or presented on a v4 network. So think about if somebody's trying to be cutesy and obfuscate or hide what they're doing by putting in on v6 and thinking nobody's going to find that FTP server, you can find it. So half scan 6. You can look at it. I think it's a good product. It does SIM port scanning. It starts from 0, goes all the way down through unless you specify a range. So it'll just tell you it's timed out and keep going, and then it reports what's open. So I think Nmap does a better job, but again, for completeness, just to cover all the v6 native tools, that was one of them. Metasploit, it supports natively it supports v6 if the stack below it has v6 enabled. So If you don't have v6 enabled on a box, guess what? You can run it until you're blue in the face. It's gonna give you some Ruby errors and some other stuff, and when you go Google it, it's gonna say, this has been resolved in an older version, and then you realize, oh, yeah, that's right. I disabled IPv6 on that box because I didn't think I needed it. So you gotta go make sure you re-enable it on your test box. One of the things that it actually does is it uses ARP. So you're thinking, well, IPv6 doesn't use ARP. Well, one of the things that it actually does require in some of these is it actually does require that you have an IPv4 address added in there. And you'll see it in a second. So for a local host, you can put in a v4, v6 address. For the remote host, you can put in a 4 or 6, and I say 6 as in sometimes, and you'll see why in a minute. So what does it include? It includes some discovery modules. So it does the local ping discovery, so I can see who's out there using the multicast. I can do a neighbor discovery, and I can see who, basically the router advertisements. I can see who is the routers out there. So actually, I want to jump back over here. All right. So remember I said it uses ARP? So it's discovering the addresses via ARP, and then it says, it compares those, or actually says, do you have an IPv6 address? Can you tell me what it is? So that's one of the things it does when you're actually running the IPv6 neighbor discovery. It's kind of cheating in a way. So if you were to change this and you were to set it to a, let me try it. You were to set it to a, oh, come on. All right, so the demo gods are failing me. Oh, there it is. So you can change the R host to that multicast address, right? So if you were to do that, and this shit's got some lag in it, essentially what happens is it returns nothing. It tells you it found the host, but it doesn't return your information. So see if I captured that, because I knew that might happen. So here's what it looks like when it says, hey, I found some stuff via ARP. This is what it looks like. And so then it says, I found those 2 IP addresses, and they map out to this. I guess I didn't. So we'll work on getting that worked. So NCAT, it's the Nmap version. So, so it's the Nmap version, I guess, of Netcat. It's the one that supports v6 natively. So you can do the same thing. I can do a banner grab. I can do whatever I want. I just have to specify it. Now, the one quirk here is you have to specify the interface address, which becomes important, especially when you're dealing with Macs, virtual machines, and other devices. It changes, so you got to make sure that you're aware of what you're dealing with. So you can actually grab that. You can do the same thing. You can do a get or whatever you want for our head for an HTTP server. Find out what it is, and it'll show you all of that. And I think I've got an example. Yeah. So here we're just running NCAT, and we're running it against a web server which is running Tomcat. And so essentially, if everything works, it should come back and it should say the same thing that we're seeing up here, but yay. So it returns a 200, so everything's okay. It tells me the server. If it was an IIS box, it would return more information. But I wanted to go with Tomcat on this. So essentially, it does the same thing as what we've already seen and we're used to. And then you've got Netcat 6, which is NC6. So versus running NC, you have to run NC6. And it does the same exact thing. The difference here is NC6 actually supports v4 and v6. So you can switch back and forth. You just have to specify it. Now, if you don't specify, it'll actually try 4, and then it'll try 6. Kind of interesting. SOCAT, native tool that supports v6. It's a great tool. If you got tools that don't support natively v6, or they say they do, you can use SOCAT to actually to use a tool that is not natively support that. NICTO. So what I've essentially got is a SOCAT listener here that is listening on port 8888. It's redirecting it using v6 over to the Windows box using port 80 via the Ethernet interface, Ethernet 0, so it's use E0. And so I can rerun NIC2, and essentially all I'm telling is the host is my local host, and I want to have it scan port 88888 or 8888, which is essentially going to redirect it over to the Windows box using V6, because NIC2 doesn't support V6 natively, doesn't know anything about it. So it should come back and it should give me some information and tell me, yeah, this is what it is. And of course, I've got the screen up above because I knew this was going to happen. So, but it identified it, Apache Coyote 1.1 tells me the target port. Granted, that doesn't match up, but still, you could document this very easily to show I ran this tool, I targeted this particular tool against your box using SOCAT. Take 2 screenshots, you're done. Move on to the next target. So, yeah, it's great for tunneling. So then we come to the THC IPv6 Attack Toolkit. This is a freaking awesome set of tools. I mean, this is like, if you don't grab anything, grab this. So Alive 6, very simple. Just run it. It'll say, hey, tell me who's out there. So it actually has them, by doing a solicitation, for a neighbor solicitation and a router solicitation, tell me who's out there, who's alive. So it's very simple. It comes back, returns it all to you. Detect New says you can run that, and it'll show you when a V6 device comes online. Start that in a window, throw it aside. Kind of just keep it up. That way you can see when something pops up. Now you can generate neighbor solicitation requests using SendPs. THC ping is okay if you want to handcraft stuff. Trace is just a version, trace route, for V6. So this is what the command line looks like that allows you to run some stuff. You can do, output all of this, which is great because if you're trying to show this for a customer, it's really cool. Actually, I've got that. So, hey, so that one returned. So let me pop up a new window. Damn, this is slow. All right. So this is what they look like after you get done building it, and I hate that it's green, but I do it for documentation purposes, so the customer doesn't have to print out black pages. It's all white, kind of looks cool. But anyways, essentially these are all the sets of tools, and so if I just run Alive 6, I get that, but I can also tell it that I want to know what the interface, what's hanging off of this, and so it'll actually start telling me what's alive down here. The only thing I had to specify was my interface. So it tells me it has one system alive, which should be correct because that's the one box we've been screwing with. Commercial tools. This is funny when you start talking about commercial tools that support IPv6. Read the fine print on what it actually supports. Nessus supports it, but Nessus, you have to give it an interface. Well, if you're running Nessus on a Windows box, what's your interface name? Does anyone know? I'm sorry? You have to give it the whole thing, which sucks. So if you're running on a Linux box, it's significantly easier. It's just like ETH1, ETH2, whatever, ETH0. OpenVAS has had support. Nexpose's had support. Saint, all of these support them supposedly native. They're very quirky. They don't necessarily return the results you think you're going to get. And I will say this, from a web inspect perspective, if you think that you're going to be able to run the SQL injector, wrong. Doesn't support it. The tool itself supports, web inspect as a whole supports it. SQL injector does not because that's a separate tool. It hasn't been coded for it. Okay? So if you're looking at that, that's great. HTTP editor doesn't work. Have fun. It's not going to work for you. You're going to find that a lot of these tools that say they support it, there's little quirky issues. Core Impact supports it, but it supports finding vulnerabilities, not necessarily in exploiting them. It doesn't necessarily support all of the things that you would think that it would. So it says, I know of and of course they have listed vulnerabilities, and this is what we look for. If you don't have an underlying V6 stack, it doesn't really work. Exploitation. So if we start talking about exploitation, one of the things that we start looking at is stuff that's V6 specific. And so again, we kind of go back to the same thing. We've got the framework for Metasploit, we've got the attack toolkit, we've got commercial tools, we've got a 4 to 6, so if you're looking at internet, and then you've got SOCAT. I actually prefer to use SOCAT for just about everything because it's so freaking easy. Just target the box, start looking at the ports you want, run your tools, tell it you want it to essentially target yourself and be done with it. So the attack toolkit comes with some pretty interesting things. Parasite 6. So it's a neighbor solicitation, neighbor advertisement spoofer. So if you're thinking ARP days, it's a man-in-the-middle type of attack. You can tell somebody, hey, I'm your neighbor. Won't you be my neighbor? Remember we talked about the significance of DNS and from a V6 perspective? One of the things that you have to do is, and we generally do this as a course of a reconnaissance, is we'll brute force DNS servers externally to see what we can get. What names are you not telling us that we can find? Well, there's a DNS DIC6, which that just sounded wrong, but DIC6 that that essentially is a DNS brute forcer, does a dictionary attack against a DNS server. So if you're thinking Fierce 2, it's kind of like that, only not as cool. But it still does the job. Fake router announcement. This is actually my favorite one in the sense that you can announce that you're the router for a local net. And so all their V4 traffic is going off to the Netherlands and having fun, and you're getting all the V6 traffic coming straight to you. The interesting thing is 445 traffic, 139 traffic, all of that, it's still active on V6. So while they may be able to see you, most tools can see you on a V4 network. They're not going to see what you're doing. So if I've attacked domain controllers before or tried to grab credentials, that's a perfect way to do it. Think about the evilness of that. Somebody sitting there going, well, we can see you if you're actually doing this because we're monitoring the V4 network and people are experiencing a slowdown or a lag in authentication. And we see that you're the guy that's doing that. Who, me? I'm not the one doing that. I wouldn't be grabbing credentials. But in this case, you can do it, and they're probably not going to be aware of it. But all of that authentication traffic will still try to use V4 and V6 if the domain controllers use it. Now think about native 2008. It's not hard. So redir. So you can redirect traffic. Again, this is kind of another man-in-the-middle type of attack. It's just a redirect spoofer. Yeah, you need to redirect this particular traffic. All that ACH traffic needs to come to me, please. I absolutely have to have the ACH traffic. And exploit 6, that is what actually scans for IPv6 vulnerabilities in the stack itself. So there are vulnerabilities, and what it does is it looks for them. So it's a cool set of tools. You can see that they've done their homework and added a lot. They've also got a fuzzer. So if you're looking for a fuzzer, which kind of led to that whole thing about web inspect not working. So if you find a V6 website and you want to fuzz it, good luck if you're talking, you don't have a tool that works on it, so you have to switch over, and you can use that fuzzer. Then you got some other stuff. So the implementation, it does some checks, some sanity checks, and make sure that your implementation or a given implementation on a box is actually correct. So you've got another one which is fake, MLD, which is the multicast. So it says, hey, this is the new multicast group. Would you like to join me? So or more importantly, I'm a member of that multicast, which I'm not. I'm not actually a member of it. So, but I am. I can actually say, yes, I'm a member of that. So you can see where the sanity checks and those vulnerabilities that we talked about in V6 actually exist. And again, so you can go through, you can generate fake router messages. So there's a lot of tools. I actually like the fake MIP V6. So you can borrow a mobile IPv6 address, assuming that IPsec is not needed for authentication, but you can borrow it. kind of cool, I guess, if you're out there and you say, I don't have a V6, or I don't, well, I guess thinking nefariously, I don't want to use my V6 address. I want to use someone else's, so I'm going to borrow theirs while I do this Bo Woods mobile attacking type of fake advertiser. I can announce myself on the network. I can say that I'm on another network or this one. Again, Smurf 6, R6. You got the local version and the remote version. The remote version only works against Linux at the moment, but they have said that they're going to update that, I think, in a couple of months. So Metasploit. So Metasploit, in addition to how do you run it? Because I mean, you know, natively you can run Metasploit against IPv6 just by giving it the actual rhost value of that v6 box you're trying to target. But they've included, or there's some other modules, and one of them just got checked in like 4 days ago, and this is vicious when you think about it. If you don't have v6 natively installed on your box, specifically Windows, it'll install it. It sets a static v6 address on it. Then it creates a bind shell payload, and then installs that as a service and sets it to auto run. Now, you know the address when you created it, so obviously what's it going to do? It's going to give you a portal back into that. That's pretty damn cool because most people would never even see that. So then, again, you've got the normal exploits that are included, all work. 06040 works just as good on V4 as it does on V6. So don't forget to try those when you're starting to map out the V6 networks, to look at it, to say, hey, let me try this. And the reason why that becomes important is because as you start moving down, or as you start moving within a network, most folks have, you know, like IPSs, iSensors, whatever out there that they're using to monitor your activities. And they may be blocking or stripping out some of the payloads, especially with some of the more advanced IPSs out there. So in this one particular case involving that data center, the folks had an IPS that was only looking at V4 traffic because that's all it was capable of seeing. So V6 traffic was allowed to pass natively, unfiltered, didn't do anything. So while I thought I was going to get a shell and was getting pretty frustrated on a couple of boxes, when you start switching over to V6 and trying it, lo and behold, what happens? You get a shell returned to you. So there's nothing better when you start doing, you know, sessions, sessions, I1, and all of a sudden you've got a Windows prompt there. So it's a good way to do it. Now, I've kind of been doing the demo as we've been going along. So I guess to kind of bring this full circle, one of the things that you've got is most organizations have a crap ton of V6 traffic out there. Think about all of the boxes that are out there that were in those operating systems that I listed. How many of them by default have turned off V6? Almost none of them. Now think about your IT admins, and I'm not trying to say anything disparaging about IT admins because they do a wonderful job in most companies, but think about the guys that are struggling to get systems deployed or build an image. Do they necessarily disable V6 on those? No. So you may have targets of opportunity sitting there that you're never aware of. So if you look at it, you've got Windows 7, Vista, to a lesser degree, I don't know very many corporations that are running Vista, but you got Windows 7, you got Server 08, you've got Macs out there that may or may not have it. Now, if they have a DHCP or a router that can give them the local link, then absolutely they will get a local address. It'll be auto-assigned. Linux and Solaris, they all ship with it enabled by default. And they all do auto-configuration. And again, that's why I caveated the Macs, because it's the one quirky, it's the prima donna that has to be different, that, you know. But the other ones, by default, will get an address. So if you can say, tell me who's alive, then you can find them. You can find them. You can target them. Tunneling. So this is something that if you're looking at, so we did a talk at, what was the talk that was here in Atlanta? Shit. No, not ShoeCon. The one that, B-Sides. I don't know why it escaped me. B-sides, and we talked about data exfiltration. And so a lot of folks have done some research on data exfiltration, and one of the things that we actually kind of looked at was tunneling traffic using V6. Would it be allowed? If I had a Torito or a 6-to-4, or I had my own broker, could I do it? And yeah, you can. Most folks wouldn't see it. DNS traffic on port 53 is very rarely looked at. IPv6 traffic being tunneled over port 53 is very rarely looked at. So yeah, it can be done for data exfiltration. Another thing that you have to be concerned with is if you're tunneling traffic, does that traffic include any type of encryption? Remember we talked about that it's recommended, but you can use end-to-end encryption, IPsec, in a V6 tunnel. So that's interesting when you start thinking about that. If I could create a V6 tunnel between me and my house, I can suck off data at will. I mean, my only constraint is the download speed at either end. So whatever the choke point is, that's where the limiting factor would be. So again, tunneling traffic, unless you're a terminator on that, you're not going to be able to look at it. And even if you did, you probably wouldn't recognize it because most NetFlow analysis engines out there look at V6 traffic, especially stuff that's encrypted, as normal V6 traffic and will flag it as V6 traffic, but you have no idea what's in it. Another one, so we talk about kind of it's known and it's out there, so you've got that rogue traffic, the stuff that you don't know about, specifically those bots, the CNC type stuff that was using V6. One botnet specifically used V6, hiding itself as IPv4 so that it could make it through routers and nobody was the wiser. So, obviously there was some security researchers in Ambella and Georgia Tech that were involved in identifying that traffic and figuring out, wait a minute, this is actually using V6, and that's not cool. But they were able to at least figure out that it was using it and find the CNC server and find the endpoint and then start working on figuring out what this particular bot was targeting. What was it being used for? Illegal file sharing. So if your ISP, Comcast or Satan, whichever one you want to call them, is filtering you or throttling your bandwidth, and you want to be able to make sure that they're doing it because you're running a torrent or downloading torrents or seeding torrents, and let's say it's absolutely legitimate, you're just you're presenting or sharing out like Iron Geek does when he gets videos, shares those out or ISOs or whatever. So it's legitimate, nothing illegal. Let's suppose it is illegal. You can use V6 and that can be used for peer-to-peer communications and most folks wouldn't be able to see it. So I guess the main takeaway was, and the biggest kind of oh crap moment for me was that once upon a time we only used V4. Now there's V6 out there. So we need to be concerned with more than just one protocol. I think that as times change, we need to change our activities. So we need to make sure that we're aware that our tools work and how they work. And I think the biggest thing that I kind of took away from it was pretty much what you can do with V4, you can do with V6. It's just a different way of doing it. But for the most part, it's pretty freaking cool. So that's it. Shameless plug. Got any questions? I think Bo was first. Well, at a router perspective, it's most definitely not configured by default, which is why when we talked about why do I need a broker, why do I need to tunnel that traffic through, and really that was the focus of why I was looking internally. Because, I mean, think about it from that perspective. If it's internet facing and it's a V6 address and you put it out there, somebody's made changes somewhere. Okay. But from a stack robustness, obviously Cisco has been a player a long time. Juniper is kind of stepping up from a firewall perspective, and I think they've made it significantly easier, and I hate to say this, but to misconfigure something from a V6 perspective. And I think a lot of people would understand when they look at a V4 and you're looking at an ASA, that's easy to understand. I mean, hell, it's Checkpoint's interface. They just stole it and threw it on top of it. So it's like, hey, I know this. Bam, you know, click, 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 close that ticket. So, you know, the idea is it's easier, but that's why I was really targeting internally. Because, man, there are so many targets out there that are ripe, and switches will pass it. They understand it natively. And so you talked about like VLANs and stuff. Guess what doesn't respect VLANs? Because it doesn't know the concept of VLANs. I have to know what my router is, and so that's why it's kind of a PETA when you're using a Mac, because you have to essentially, if you don't have, you know, you're plugged in and you're trying to use native tools on a Mac to do an assessment, I wouldn't recommend that, but I'm just saying if that's what you're trying to do, you do have to have a router advertisement give you the local link. Okay, or you have to have a DHCP6 server give you an address and say this is what we want you to use for the local link. You need to auto-configure the rest of it, because part of that is based upon your MAC address and other things. So that being said, if you were using Backtrack or Ubuntu or whatever your tool of choice was, you know, for a distro, you could very easily get on get a 6net IP address and start looking at those, and that's really what I guess. I mean, I'm going to be honest, it was embarrassing standing there having a guy tell you, you missed half our crap. Because you just don't, I didn't think that way. I just, because, you know, you look at targets and you say, okay, you've given me these subnets, this is what I need to go after. So.
If I walked into a place and I'm plugged in, say, the Twitter network, they've segmented their IPv4 and they think they're all like awesome. Now, I'm on the Twitter network, but IPv6, I can still see the server network. I get through like all the switches and everything. Or in a lot of cases that may work, in some cases it may not.
It depends, because there could be physical segmentation there. Okay, so that would be one thing. And if you're talking trunking, now you're talking a complete change, because I do have to have, there has to be some configuration that is made that would not normally be done on a V6 side that you would do on a V4 to get that configuration in place. Does that kind of make sense? So think of it as, and come on, man, I'm not speaking out of school here when I say most networks are pretty damn flat. So it's not like you're going to have a difficult time finding some targets, but yeah. So, did that answer what you? Okay.
I was kind of a little in the same category, but with response to NAT and what is happening with NAT. Are we actually going to, because from your previous responses, I know we have internal, fake IPs just like we have for IP4. Are you really thinking that NAT's going to be destroyed? We're not going to continue to
actually no, you don't use a fake IPv6 address. You use one that's built using part of the requirement is it has to have your MAC address. Okay, so think about if I've been given a V6 address or subscribed to get a V6 address, how would I deal with assigning that? So for an auto configuration, it creates an IPv6. I mean, dude, you're talking that whatever that large ass number is. The idea of you getting a collision between two V6 addresses is pretty slim to none. I mean, think about it. It's not going to happen.
Yeah, I understand
so,
that, but I mean from the infrastructure internally on the network where we're used to having these NAT addresses, and your idea is that we're not still going to implement the same possible frontier that we already have. We're going to go back to doing completely public addresses on our internal networks?
no.
That's what I'm trying to get to. So
No, you would then have a set of IP addresses that are publicly accessible that you would still be assigned, and so. But the notion of using NAT because of the fact that we have to use NAT, you don't necessarily have to in a V6 environment. Does that make sense? In the sense, you have to, well, unless you're at a university, man, most people are going to have to use some sort of NATing in their environment because they don't have 10,000 or 20,000 or 70,000, depending on the size of your company, IP addresses readily available. And if they did, the Chinese want to buy them because they're like 40 million short. Because apparently they hadn't figured out what natting is. So, anybody else?
What about spoofing? What about spoofing addresses? Like since since I know IPv6 address is supposed to be based upon the MAC address, if you want to spoof someone, you're basically going to have to either figure out what their MAC address is or just kind of guess.
No. So you can actually advertise yourself as that address, and if the other one was auto-configured, not statically assigned, or even if it's assigned by DHCP v6, it will say, wow, there's a collision here. You know, we have duplicates. I need to get a new one, and so it'll generate a new one based upon. And part of the generation for an auto configuration is it uses the MAC address for auto configuration. For DHCP, it says these are the scopes that you have available for you to be able to sign from. Same thing as v4. That doesn't change. So it'll essentially do. You ever seen where you have a duplicate IP address on the network? It's the same exact thing. So you can take over somebody's address if it's auto-configured or it's set to DHCP. If it's static, you both back off, and then you get into a pissing contest to see who's going to win, and chances are it's going to win. Because then the routers will actually look at the age that it's seen that particular IP address and which port it came through and start. That's where some of the intelligence built into like Cisco devices will start saying, yeah, that's the whole mechanisms they've got built in that says, no, you're not who you say you are. But again, if I'm going to take over somebody's address, it's only applicable on that local net. I cannot cross a router. Okay.
Your adventures, have you evaluated firewall scripts as far as the ones that interface with IP tables and stuff like that? Have you evaluated firewall scripts, UFW or anything that configures IP tables on Linux?
You mean from a v6 perspective?
Yeah.
No. I mean, I've done it from a v4 perspective, but never had one that required us to look at that. No. But we've done firewall assessments of ones that were misconfigured that actually did have v6 enabled and they had no idea they had done it. It's like, we don't have that. And of course, you're on a conference call and they're arguing with you, we do not have this enabled. And it's like, no. Trust me, that's not a Photoshop screenshot. It is actually the screenshot of your interface. They go look at it and they go, can we move on to the next point? Because they realize that now they did screw up and they had it misconfigured. And I'm not going to say the company, but it was a Juniper device, and it was very easy to see how they made the mistake.
Well, I recently had a few VPS. IPv6 I don't turn it off. But like I'm saying, I guess I didn't even test that, just turn it right off. But if I was to turn it back on, put any basic firewall script, work, block those ports, you know what I mean?
Yeah. Oh yeah. Oh yeah. So maybe I didn't make that clear. The same thing that you do on a v4 network from a firewall perspective is Windows, Linux, Mac. It doesn't matter. You do the same thing on the v6 side. You just run a different command to initiate the v6 side. So if you're talking IPFW, you're looking at IP6FW versus the IPFW. And so that's why when I pulled up the Mac version, you'll see that it is set by default to allow any, which
But if you said that to just block all, it would block both IPv6.
No, because this is IPv6 FW.
Really?
Yeah. So it uses different commands to control the rule sets for the given interface. The first thing you'd have to do is go through and make sure that all of them are allowed to use IPv6. A gotcha from Fusion install on a Mac is if you install VMware Fusion, it doesn't natively enable on a Mac. On a Windows box, completely different, and yes, it does. But it doesn't natively enable the v6 interface for a VMnet 0 or 1. So you have to go through and enable it.
So basically, if your organization isn't ready for IPv6 or hasn't thought about it, your best advice is go disable it across the board everywhere.
No, because I target those, so I'm not going to say that at all. I would say make sure you have them enabled and the default firewall rule set is set. In other words, to any. Just leave it like that, and we'll be good to go. I can give you a business card. You can call me. We'll come assess you and have a good time. By the way, red is good for us. Green is bad. So that's kind of we inverse that. But yeah, I say that in jest. But I think you are going to have to reach the point where you start looking at getting a transition, a plan in place. Now, is it going to be this iteration of Windows 7 or whatever? No. But when you know by default they're turned on, you've got to take that into consideration and say, I've got a hole here that someone's going to look at.
But I would turn that off in policy as soon as possible on Windows. And I would blacklist it across all my Unixes just to take it out of the equation today. If I don't know what I'm doing with IPv6, I don't want it on my network.
And that's a fair statement. And again, remember, I have a myopic view. I target that, so that's the one I would not suggest you turning it off. But in reality, when we write up we do recommend, and it goes with any service, if you do not need that service, disable that service. If you're not using it, turn it off. After we leave, after we leave your engagement. So, I'm sorry, go ahead.
There have been rumors that if you try to uninstall the IPv6 from Windows 2008, it breaks it. It breaks Active Directory.
Yeah, and in fact, that's interesting you should say that, because if you look at the AD 2008 and you start looking at the DHCP settings, natively built into it is V6 built right into it. So if you've seen it, you know how easy it is to check one box and then I'm screwed. Because guess what? It's going to start looking and saying I can allocate those back out, but it'll more importantly do a advertisement to say this is what you have available to you.
How do you block the trade of building from dynamically building that to service tunnels? How do you block Teredo?
Hey, how do you block Teredo from natively building a 6 tunnel? And so one of the things that you have to do is you have to look. There's servers out. The Teredo servers that you're going to be connecting to, that you're building the tunnel with, are well documented. So you can go to the Microsoft's website and find they're clearly listed. I know there are certain content filtering things that go kind of a little bit deeper from a packet inspection. They will block that natively.
So is there like a layer 7 vendor that you can talk about that swacks Teredo?
Yeah, but what it actually requires is it performs an SSL man in the middle. So when you think you're going to Bank of America, you're not. You're actually going to the appliance sitting there on their local network, and that kind of pisses off a lot of people when they find out that you have the ability to look at their bank transactions and that type of stuff. But that is one of the requirements. And so you have to think, then you get into that risk evaluation. Is the risk worth the risk of losing your job for, implementing something without making sure that you have legal buy-in to do that? So, all right, man, that's it. Thanks, everybody.
Thank you very much. That was awesome. I love that video.
Oh, thanks, man.
Fantastic. I'm glad that we told you to do that one.
The other one would have been